Here we present the results of the Nortek Eco deployment done in Boynton Beach Inlet over in South Florida by the Marine Megafauna Foundation in support of their research on giant manta rays. The deployment lasted for almost 1 month from mid-April to mid-May 2020. We start by describing the location. As shown on the left, Boynton Beach Inlet is a man-made inlet connecting the Atlantic Ocean to South Florida's Intracoastal Waterway. It is the southernmost inlet in the study area covered by Peyton Marshall's 2020 paper, from where the image on the right was taken. Every dot indicates locations of giant manta ray encounters as part of that study. Due to heavy boat traffic within the inlet, the standard echo deployment method of using the timed release mechanism as shown on the left was not used. Instead, the Echo ADCP, shown on the right already installed inside of the Echo buoy, was attached to an anchor weight made of cinder blocks. The data were carefully reviewed and no magnetic influence from the chains was found, due to the fact that the buoy was sufficiently far above the anchor weight. Aerial photographs of the site were taken with a drone after the deployment and regularly during the survey. On the left, the buoy can be easily seen even though it was located more than 5 meters below the surface because of the clear water conditions at the site. On the right, it is an underwater photo of the buoy just prior to retrieval. Noticeable algal growth can be observed. Because the release system was not used, a grapple method was used to hook the Echo and bring it to the surface. A commercially available small vessel was used and no crane was required. On the right, the algal growth coverage is evident, including covering the Echo itself. However, this coverage causes no impact whatsoever on the quality of the data. Let's now discuss the data collected. Upon retrieval, the Echo's data is downloaded to the Echo app as shown on the top right. All data are automatically processed through a rigorous quality control algorithm and a comprehensive report is produced. Current data are split into 3 depth layers covering the top, middle, and bottom of the water column for easy viewing. One of the many plots generated by the Echo app are shown, where current speed and direction are plotted on a polar coordinate graph, where the top is north and speed increases as you move away from the center of the plot. The tidal nature of the inlet is observed as expected, with half of the data points on one quadrant and the other half on the opposite quadrant. Little to no variation in speed with depth is observed, which is typical of a well-mixed environment such as the Boynton Beach Inlet. Current speeds for flood tide are faster and show less directional scatter than ebb tide currents, indicating a slight asymmetrical pattern, which is not unusual. The Echo app also generates histograms of the current speed data, which are shown here on the right. Speeds approaching 2 meters per second or almost 4 knots are observed throughout the water column, with the highest currents being near the surface, and most of the data lie between half a meter per second and 1.5 meters per second. On the left, the polar scatter plot for the middle layer is overlaid on an aerial photograph of the inlet. It is clearly seen how the current direction does not align perfectly with the inlet's central axis. This is caused by 2 factors. First, the Echo was deployed next to the south wall of the inlet rather than at the center of the inlet, where the current direction is more aligned. Second, 2 exit channels exist on both sides of the inlet just to the west of the Echo's location, further influencing current patterns. Finally, careful data review, as well as a review of extensive video observations of the site, also confirm the current directions to be correct, and further document the dynamic nature of the currents in this energetic inlet. Here we present data from the temperature, pressure, and tilt ancillary sensors as generated by the Echo app. Temperature, shown on the top left, shows diurnal variations unrelated to the tidal cycle, but rather driven by night-day solar exposure in the shallow channel. Pressure data, here converted to a range to surface in meters, is shown in the middle graph, shows the mixed semi-diurnal tidal regime characteristics of South Florida, with a medium range of about 1 meter. On the bottom right, we show the Echo buoy's tilt as it responds to strong currents. Tilt stays below 8 degrees for most of the deployment, with small excursions up to greater than 20 degrees during peak current flows. Despite of these, only very minimal data loss occurred as a function of high tilt conditions. And finally, here we show summary statistics from the data. We can see how mean speeds were around 0.8 meters per second, with some reaching as high as 1.85 meters per second. Standard deviation shows the large variability, which is typical of bidirectional tidal flow sites. And ancillary sensors showed stable measurements throughout the deployment. Overall, the deployment presented superior data quality for all data types collected, with all processing done automatically by the Eco app without prior experience required.